everybody, and welcome back to another Miss Pollard YouTube video. Today we're going to be going over scientific notation and more specifically the operations of multiplication and division. But first, what's really important is figuring out what is scientific notation. We can't work with it if we don't know what it means. So scientific notation is when a number is written as a product of a factor and an integer power of 10. So that means 10 to some integer power. Let's take a look at what that really looks like. So that's going to look like a times 10 to the n power, where a has to be greater than 1 or less than 10. And that's going to be very important. It's greater than or equal to 1, and it has to be less than 10, because a lot of the times we're going to get problems where it's not in the proper format. We solved it, and it's less than 1, or it's greater than 10, and we're going to have to manipulate it to make sure it is in that proper scientific notation. And our n has to be an integer, so that could be a positive or a negative integer, that power. Let's take a look. So we have 425 million. If we put that into proper scientific notation, we get 4.25 times 10 to the 8th power. 4.25 is between 1 and 10, which is great. That's what we wanted. And 8 is an integer, so that's our proper scientific notation. We moved our decimal place over 8 times to the left, which gives us a positive exponent. And we'll go into that in a little bit. So, when we have a positive n, to go from scientific notation to standard form, you move it 4 to the right. So positive is moving to the right. If we're going from standard form into scientific notation, we go the opposite way. We're going to move it over to the left. So it's going one way and then the other way. So when n is positive, we will move the decimal place to the right 4 places. When we're having standard form, we move it to the left, put that times 10 to the 4th power. What if n is negative though? If n is negative, we're going to move that decimal place to the left. So for example, we have 3.56 times 10 to the negative 3rd. I'm going to move it over 3 to the left, and I get 0.00356. So this is the basics, a quick general overview of scientific notation. Now let's apply it to our multiplication and division problems. So, for multiplication of scientific notation, you may have different exponents. Why is this crucial? Because when we're doing addition and subtraction, they must have the same exponents to be able to continue. But for multiplication and division, we can have different exponents. So for this problem, I have 7 times 10 to the negative 1st times 4.55 times 10 to the 6th. I'm going to do exactly what this problem tells me to do. It's saying multiplication. So I'm going to take my two factors of 7 and 4.55 and multiply them together. When I multiply my factors together, then I have to add their exponents. So I'm multiplying the factors, adding the exponents. That's the way I like to remember it. Multiply and add. We're just twisting our arms. It's an important key point that you need to remember. Multiply the factors, add the exponents. So I'm going to do 7 times 4.55, and I'm going to do negative 1 plus 6. A lot of people forget that we're adding those exponents. We're not multiplying them. So I'm going to get, when I do that, 31.85 times 10 to the 5th. 7 times 4.55 gives me the 31.85. 6 plus that negative 1 gives me the 5. But then you're sitting here and you're like, Miss Pollard, wait, you told me that my factor has to be between 1 and 10. This is way greater than 10. You're correct. That's not proper scientific notation. So I have to move this decimal place over to be able to continue. So let's look up here. It is not in proper scientific notation. So to be able to do that, I am going to move my decimal place to the left. And when I move my decimal place to the left, we have to add 1 to the exponent. That's our rule. Moving to the left, add 1. So our new expression, our new answer becomes 3.185 times 10 to the 7th power. Very important here. If you think about it, when we are going from our scientific notation to our standard form, when we're moving to the left, we're getting that expression into a regular number, which means we're getting rid of that scientific notation. So I'm moving it over, and that then becomes 10 to the 0 power. It's exactly what we're doing. If I'm moving it to the left, I'm adding 1 to the exponent. So this would become our final answer. This is something that has to be memorized. When we move to the left, we add 1. When we move to the right, we subtract 1. This is so important for multiplication and division, even for addition and subtraction of scientific notation. Let's take a look at a problem with division to see how we would complete that type of problem. Here we have 5.3 times 10 to the third divided by 7.4 times 10 to the negative fifth. This is a division problem. So what I like to do is box off my factors. These are my factors. I'm boxing them off. And then I have my exponents. I'm going to circle them so I remember what I'm working with. Just like for multiplication, when we multiply the factors, for division, we're going to divide the factors, which makes sense. So I'm going to divide 5.3 and 7.4. For addition, for multiplication, we added. So for division, we're going to subtract. We're using all of our operations in these two types of problems. So I'm doing division and then subtraction. That's a cutesy little dance there. Division and then subtraction. It's a way to remember because if we divide these numbers, if we add these numbers, we are going to get them wrong. So one last time for this dance, division and then subtraction. So I'm going to divide 5.3 divided by 7.4, and then I'm going to do 3 minus a negative 5. This is where our integer operations are so important. We have to remember a minus and negative becomes a plus. I highly suggest to my students to write this out so you can visualize, you can see that minus and negative is a plus. So 5.3 divided by 7.4 gives me 0.716. 3 minus a negative 5 or 3 plus 5 gives me the 8. So that is my answer there. But once again, that's not in proper scientific notation. That number, that factor, is less than 1. So I have to move this over. So when I move it over to the right, I am subtracting 1 from the exponent. So now my final answer is going to be 7.16 times 10 to the 7th power. Everything's in proper scientific notation. I double-checked my work to make sure I'm right. So that is how we accomplish a division problem. Remembering, dividing that factor, subtracting those exponents. Let's take a look at a problem that you might see on an elevated assessment, so maybe a state testing or a school testing. Now we have 1.25 times 10 to the negative second times what number is 3.5 times 10 to the sixth. And I'm going to write this as an expression, as an equation. I have 1.25 times 10 to the negative second. Times means multiplication. I'm going to use the dot because we have an x there. Don't want to confuse ourselves. It says what number. So you can use any variable. Usually we use x as our variable, but you could use any variable. I'm just going to stick to a question mark. I know that's not very normal for problems, but that's what I'm looking for. So it could be a variable, it could be a question mark. Is 3.5 times 10 to the sixth. Now I want to try to get that question mark, that missing variable by itself. And we solve equations, we know that these two are glued together by multiplication. So we have to use their inverse operation. So if we have multiplication, we have to use division to get that question mark by itself. So I'm going to divide by 1.25 times 10 to the negative second. And that gives me this new problem. I can box it off to see we're just using our division of scientific notation, just like we just saw. So I'm going to do 3.5 divided by 1.25. When I put that in my calculator, I get 2.8. I'm going to subtract my exponent. 6 minus a negative 2 becomes that plus again. A minus and negative becomes a plus. So 6 plus 2 gives me 8. So times 10 to the 8th power. Now I'm going to look at it. Is 2.8 between 1 and 10? Yes, it is. So I'm good to go. And I subtracted. My exponent is an integer. So everything checks out. This might seem a little scary at first, but once you apply our knowledge, this is what you get. So 2.8 times 10 to the 8th is our question mark, our missing variable, whatever you want to call it. So this video was all about learning our multiplication of scientific notation, where we're multiplying our factors, adding our exponents. For division, we're dividing our factors, subtracting our exponents. And I hope this was helpful for you to understand scientific notation, multiplication, and division.